हाँ जी, so हमने भी कुछ बेसिक अल्केन्स के स्ट्रक्चर पर आकर इस चीज को स्टॉप किया था and we're going to resume from there. We were talking about different kinds of formulae, and here what you see is another kind that we didn't put in the document yesterday, and that is a 3D model. We also call it a ball and stick model, but that's not important because those are just the diagrams given to the students to understand, to properly visualize a molecule. Those are not important in terms of exams because usually in exams, what they consider are these structural formulae or these structures which help you to describe the compound with the number of atoms or different types of atoms they have. And in the same way, to write it quickly in exams is easily possible. It does not take up so much space. It's easier and quicker to go with. So these 3D models are just there for the imagination. However, the actual structural formulae are the ones that we're going to use. Now, we were actually going through these names one by one in yesterday's class when we stopped. So I'm going to revise a little bit of that and complete whatever was left off from yesterday. So starting with methane, this is methane over here, and it just consists of one carbon. Now, in this case, it has 4 hydrogen atoms, so that would become CH4. So as you can see, carbon is in the center, all 4 hydrogen atoms are surrounding it, methane, CH4. Then comes ethane, C2H6, in which there are 2 carbon atoms in the center and there are 6 hydrogen atoms on the side. In this case, what's different from methane is that it has 1 more carbon atom, which is singly bonded to the other carbon atom, as you can see over here in the structure. Okay, just a minute. I'm going to use the spotlight in order to make sure that you understand it. Okay, so the carbon-carbon single bond is here, and they're connected to hydrogens in such a way that 1 carbon is connected to 1, 2, 3 hydrogens directly each. And the other carbon would also be connected to 1, 2, 3 carbon atoms, hydrogen atoms, sorry. So this is the structure of ethane. Then comes propane, 3 carbon atoms, and there is a total of 8 hydrogen atoms. Yesterday, I did a small exercise, and I probably asked Soha, I don't remember the student exactly, but I probably asked Soha to count the number of atoms of carbon and of hydrogen in pentane. She did so, and that's how you can come up with a molecular formula. So this is CH4, this is C2H6, this is C3H8, C4H10, C5H12, and C6H14. That's how the formulas go. Not just that, we had understanding of general formula yesterday, by which we can calculate the formula of any alkane in the family. Any, no matter it contains 20 atoms of carbon, or it contains 40, or it contains more, or it contains less. That doesn't matter, right? So any questions so far?
सर जनरल फॉर्मूला एक बार से यानी उसका फाइंड आउट कैसे करते हैं वो रिवाइज कर दें.
That was CnH2n plus 2. So from the number of carbon atoms, you simply multiply them by 2 and add 2 to it. You'll get the number of hydrogen atoms. For practice, look at this. There are 1, 2, 3, 4, 5 carbon atoms. So how many hydrogen atoms are supposed to be there? 5 multiplied by 2 is equal to 10, plus 2 is equal to 12. And if you count, there are actually 12 hydrogen atoms over here. So from general formula, you can draw the structure, and from the structure, you can come up with the molecular formula. But from a single structure, you might not be able to come up with a general formula. However, as in this book, as a part of easy steps and recognizing the structure, we may come up with a very good guess. Okay, so far at this level, but as soon as you go to a higher level, this becomes a little bit difficult. As the types of compounds reach to such a high value, it's not easy. Then you take the help of the data in order to come up with general formulae. Any other questions before we move on?
No, sir.
All right. So moving on, actually we need to go a little bit back. So these were the types of formulae that we discussed yesterday. Molecular formulae giving actual number of atoms present. They get structural formulae giving the number of atoms and how they're bonded, means all the bonds. Empirical formulae which gives the simplest whole number ratio. These are written in this order because whenever we go with an experimentation technique, what happens is that we first calculate the empirical formula, then we convert it into molecular formula. The molecular formula then be converted on structure as your perception about the compound if you know which family it belongs to, right? So we did the same thing back in chapter number 6. It's nothing new. It's all a part of revision. Back in chapter number 6, if we knew the percentage composition of the individual elements, we could always come up with an empirical formula of compound, and then we had further formula, further mathematical steps to solve what would be the molecular formula. And in this chapter, it's easy for you to understand what is the structural formula. I would also practice that back in the bonding chapter. So it's easy how to work between all of these formulas if you know the exact steps to do that. Now, there are a couple of more pieces of information in this portion which we need to understand. So what I'm going to do is that I'm going to talk about page number 255, left-hand side, third paragraph from top. In organic chemistry, the structure of a molecule is very important. Figure 10.4 shows the structural formula of first 6 alkanes in the series. We just went out with this figure. We understood each and every structure step by step. Methane, ethane, propane, butane, pentane. How they are named is something else. That is known as nomenclature. Nomenclature is actually the art of naming. We have studied the nomenclature of inorganic compounds back in chapter number 3. However, organic compounds are named differently. We'll study that in this chapter after a couple of topics. And not to mention, in science, nomenclature is a proper art, is a proper scientific method that we follow. So you probably already have followed that in your biology book of how to name organisms biologically. So you're familiar that nomenclature is a proper branch in which we study and understand how to name different things. In case of biology, how to name living species, and in case of chemistry, how to name compounds and molecules. All right. So we'll do that a little later, coming to the same line we were at. Um, the figure showed the structural formula of first 6 alkanes. A structural formula shows the bonds between the atoms. As the length of hydrocarbon chain increases, okay, the strength of weak forces between the molecules, which we call intermolecular forces. We taught this definition back in chapter number 2, or we also call them van der Waals forces. This is the type of intermolecular forces. There is not much explanation about these forces in your book. However, what I need you to write over here, and I'm going to write that for your ease over here so you can copy it on your books. Van der Waals forces are the forces present among the molecules of an organic compound. Okay, so that's how you can write it on your book. Are we clear? Any question about these forces? Because that's about it. That's where we draw the boundary line. Van der Waals forces are not discussed any more than this definition in your book, and usually this definition isn't even a part of your paper. If you take a look at your past papers, aren't much questions about Van der Waals forces. There would rarely be one or two questions, and the same line is discussed in that question in past 10 years. Yes,
So
someone?
intermolecular forces भी कर सकते हैं ना?
This is a type of intermolecular forces. Intermolecular forces is not just of one type. They're further bifurcated into many types, although all of those types are taught in A levels, not at the level of IGCSE. But yes, one of the names are in there, Van der Waals forces. Van der Waals is the name of the scientist. So yes, a type of intermolecular force.
तो उसे हम यहीं उसको नाम लिखेंगे, कोई पूछेगा?
हाँ बस, that's about it. If you are asking कि IGCSE में क्वेश्चन कितना आ सकता है, तो बेटा इसके नाम से आगे कोई क्वेश्चन नहीं आता कि कौन सी फोर्सेस प्रेजेंट होती हैं. आप कहेंगे इंटरमोलिकुलर फोर्सेस सच एज वैन डर वाल्स फोर्सेस, या सिंपली आप वैन डर वाल्स फोर्सेस लिखते हैं, that's good enough. You only need to mention the name. You do not need to discuss the details of this, because details are beyond the requirements of IGCSE. Are we clear? Sir. Good.
Yes,
good.
Sir.
So the thing he's trying to talk about here by discussing these van der Waals forces is that, just a second, is that when these forces are increased, what happens that the boiling points of the members of the series also increase. Not just the boiling points, the melting points and the boiling points both increase gradually. So what we are going to do over here is that we are going to discuss this table. Okay. Okay, the table at the bottom of page number 255. The first 6 alkanes are written over here, the same names, the formulae that we discussed, for which the structures are given in the next page, the figure that we just went with. Take it. So let's go with the names, row by row. This time I'm going row by row. Methane, that is CH4 according to the general formulae. It has 1 carbon atom only. The boiling point is -164. It is a gas at room temperature. Ethane, with 1 more carbon atom, with actually 2 carbon atoms with the formula of C2H6, has a higher boiling point, is still a gas. Propane, 3 carbon atoms, higher boiling point, still a gas. Butane, 4 carbon atoms, higher boiling point, still a gas. But as soon as we move to pentane, it has a higher boiling point, and now it's a liquid. So as the boiling point increases, we can see the state of matter is getting changed. Why? When we're going to cross for the boiling point values, the room temperature value, which is usually 25 degrees centigrade or 20 degrees centigrade, anything having a boiling point higher than the room temperature is a liquid at room temperature. So if these values would increase, there would come a point when the alkanes would be solid at room temperature. And yes, that is exactly true. That's what he was about to say in the last lines of this paragraph. Let's go through these lines. Under normal conditions, try to follow the spotlight. Under normal conditions, the first 4 members of the family are gases. Those between C5 and C16, which in short are called C5 to 16 alkanes, are liquids. The compounds in the family with 17 or more carbon atoms are waxy solids. Okay? Actually, when it goes beyond than C26 or 27, they're hard solids. Okay? So you can add it over here. Beyond carbon 27 are hard solids. Beyond carbon 27, the alkanes are hard solids. Are we done writing?
Yes.
All right, make sure all of you write that on your book, because these are the extra pieces of information. Unfortunately, we cannot make a copy because of all of these online classes. We needed a lot of information to be set in a proper way, but I need to go according to the book, so that's why we are writing on the book. So we are adding a couple of points here and there to make sure that we have all the information we require for the exam. Now, in this table, you would see a huge arrow face downwards with the word saying boiling point increasing. Here you need to write a couple of more things. With boiling point increasing, the melting point also increase. So you should write MP increasing and density increasing. And of course, all of these thermodynamic values, mass-based values increase as the boiling point increases. Are we clear? So here at this point where BP increasing is written, you're supposed to write MP increasing and density increasing, because all of these values increase with increase in the boiling point. Gee, do we all understand? Any questions before I move any forward? All right. So from this page, we have understood that there can be different physical states at room temperature for different alkanes. As we go higher, the intermolecular forces increase, the attractive forces increase, hence the state of matter changes. Hence the boiling point value or the melting point value or the density value also changes. The change is, however, an increase, because as the number of carbon atoms increases, all of these things that we have discussed about, melting point, boiling point, density, uh, and the intermolecular forces, they all increase. Physical state, however, changes from gases to liquids to waxy solids to hard solids. All right. So moving on to the next page, I am going to skip the properties of alkanes over here, and at the bottom of, sorry, at the bottom of page number 256, I'm intentionally skipping the chemical reactions part. We're not yet supposed to study that. There are a couple of other things that we need to study before we start studying the chemical properties. So there is a heading at the bottom of page number 256 that says a homologous series. I hope from biology you're familiar with the word logos or logi, the last term of biology. It means to study. 1120. 1120. All right. So homologous series, the family of alkanes has similar chemical properties, and we can study it with the key definition given on the next page. Take a look at that key definition. They have the same general formula. For example, for alkanes, we had the formula CnH2 and plus 2. They have similar chemical properties. All alkanes will show similar chemical properties. We're going to study that next. They show a gradual increase in physical properties, such as melting point, such as boiling point, such as density. We've already studied that. And you're going to add a fourth point in there, which is not written over here. And I'm going to write it over here actually. They contain the same functional group, which requires us to define what functional groups are, but we'll do that a little later. This is the fourth point to this key definition. Make sure you write the fourth point. Homologous series, its definition, I mean these four simple points, they have been a part of past papers way too many times. So this is considered very important. What is this? Homo means same, logos means study. It means the study of same components. Series define a family of organic compounds, all the compounds which can be studied under the same way. Okay. So what I'm going to do over here is that I'm going to go a little off topic, and I'm going to explain you a few things before we can come to this simple definition, homologous series, or how a family can be studied. Okay? Let me explain it in a two. बेटा आपने नोटिस किया कि एक कार्बन वाले को हमने मीथेन कहा, दो वाले को इथेन कहा, तीन वाले को प्रोपेन कहा. The list goes on. कार्बन 4 हो सकते हैं, 5 हो सकते हैं, 6, 10, 20, 30, और इस तरह से काउंट इंक्रीज करती जाएगी. या जितने नंबर ऑफ कार्बन एटम्स होंगे, ठीक है, उसी तरह से तरतीब चेंज होती जाएगी. But let me tell you, they aren't always arranged in the same way that they have been shown in the diagram on this page, on the previous page. This one, they can be arranged differently. So let me tell you, just talking about butane, it can be arranged in 3 different ways. Pentane 4, moving on to a molecule which has 30 carbon atoms, can be arranged in 4 million different ways, approximately. I said 4 million. Okay, so that's a huge count, which usually make the alkane family to contain millions of compounds in different arrangements, in different properties, in different behaviors. All right, do we understand this? So, how are we just going to study all of these compounds? Homo means same, logos means study. So it means that we can study all of these compounds. And now I'm talking about millions if they have these 4 same things. And if they have these 4 same things, they can be called as homologous series. So alkane is one of the homologous series. Alkenes, which is our next topic, I mean the topic after that, not exactly the topic right after this one, but the next homologous series in the chapter would be alkenes. Then there would be alkynes and alcohols and carboxylic acid, and the list goes on. So basically, जिसे पहले मैं family कह रहा था, जिसे अभी भी हम family के तौर पे define करते हैं, the word is also written over here. For that, we have chemical word, and the chemical word is homologous series. Okay? Although we do use the word family in case of simple understanding, but that's not a chemical word. The correct chemical word for that would be homologous series. यानी वो सारे compounds जो एक तरह के हैं, जैसे आप एक certain family से belong करते हैं, वो सारे लोग जो एक ही blood से हैं और आपस में relatives हैं, वो एक family कहलाते हैं. इस तरह हमारे पास जो compounds होते हैं chemistry में, organic compounds, जिनका जनरल फॉर्मूला भी एक हो, जिनकी प्रॉपर्टीज भी सिमिलर हो, जिनके फिजिकल प्रॉपर्टीज में बड़ा ग्रेजुअल से चेंज आता और जिनका फंक्शनल ग्रुप भी सेम हो, विल डिफाइन द फंक्शनल ग्रुप वर्ड लेटर, तो उन्हें हम सेम पैटर्न पे स्टडी करते हैं. सो वी कॉल दैट अ होमोलोगस सीरीज. तो अब इसमें जितने भी मिलियंस ऑफ कंपाउंड्स हैं, उन सारों को हमने एक ही तरह से डिफाइन कर दिया और उन सारों की फिजिकल प्रॉपर्टीज वैसे ही चेंज होती हैं जैसे अभी हमने पिछले टेबल में किए हैं. उन सारों के स्ट्रक्चर्स उसी तरतीब से बनते हैं जैसे हमने पीछे फिगर में किए हैं. उन सारों के अंदर अट्रैक्शन और दूसरी प्रॉपर्टीज बिल्कुल वैसी ही होंगी जैसे हमने पीछे डिस्कस किए हैं. So homologous series makes it easy for us to discuss all of that. Are we clear? I just want to make sure that all of you are clear. So what about boys and girls? One of you can speak on the behalf of boys and one of you can speak on the behalf of girls. Are we clear? Or do we have any questions?
Yes, sir.
Good, good. So if you're clear, I want to stop it over here, right here, because the other topics I'm going to start with cannot be stopped in between. For example, the art of naming a topic is something that we're going to do yesterday. Tomorrow, tomorrow, and I'm going to start with a new topic that would be nomenclature, how to name these compounds. Okay? And inshallah, we are going to do it in one go because I don't want to stop it in between. Otherwise, I'll have to repeat the whole thing of yesterday on the next day's lesson, and that would come quite hectic. In this practice, we'll understand how do we come up with these names, as you can see over here, that we have these names: methane, ethane, propane, butane, pentane, hexane. How do we come up with these names? So this is something that we are going to study. Now, when it comes to nomenclature, okay, nomenclature in detail is not exactly a part of O levels. इसमें बहुत थोड़ी सी माइनर सी डिटेल होती है. मैं एक पॉइंट यहाँ पर क्लियर करना चाह रहा हूँ जो इम्पोर्टेंट है, और वो इतनी माइनर डिटेल होती है या इसके क्वेश्चन इतने कम होते हैं पास्ट पेपर पे कि समटाइम्स टीचर टेंड टू स्किप इट. वो बच्चों को कहते हैं कि जो 6 नाम 7 नाम लिखे नजर आ रहे हैं और इस पूरे चैप्टर में कोई ऐसे 15-16 नाम होंगे वो आप सारे रट लेंगे. ठीक है, आई एम नॉट इन द फेवर. राइट, होता क्या है, ओ लेवल्स में टीचर बच्चे को नॉमेनक्लेचर पढ़ाता नहीं है और ए लेवल्स में टीचर रिज्यूम करता है बच्चा ओ लेवल से पढ़ के आया होगा, और जो दोनों एंड्स पे नहीं पढ़ा होता वो बेचारा फंस जाता है क्योंकि ओ लेवल में नॉमेनक्लेचर काफी कॉम्प्लिकेट हो जाता है, ए लेवल में सॉरी. तो हम क्या करेंगे कि हम ऐसा करेंगे, मैं इसे ओ लेवल में स्किप नहीं करवाता. जितना नेसेसरी नॉमेनक्लेचर है मैं आपको मेमोराइज या क्रैम करने के बजाय आपसे ये कहूंगा कि आप इसे उसी तरतीब से समझें, ठीक है, ताकि आप कंपाउंड्स को खुद नेम करने के काबिल हो जाएं, ताकि जब आप ए लेवल्स के लिए या एफएससी के लिए, दोनों की बात हो रही है, उसमें जाएं और टीचर ये अज्यूम करता हो कि आपको कुछ ना कुछ नॉमेनक्लेचर आता है, तो आपको एक्चुअली में वो आता भी हो, ठीक है। तो इसलिए हम कल को नॉमेनक्लेचर करेंगे, ओ लेवल की जितनी बाउंड्री है उससे स्लाइटली आगे जाएंगे, उससे ज्यादा करेंगे, ठीक है, जस्ट टू मेक श्योर that you can do it on your own and you're independent in this before you go to FSC or A levels, ठीक है। And when you're going to go to FSC or A levels, you'll be good enough to understand what you are. Okay, sorry, that is spelled like this, nomenclature. Okay, I'm actually going to move to that page in the book. I see I'm talking about a word that is a little bit difficult. Where is it? I think the word is not written over here in the book. Yeah, the word is not written over here. They simply use the term naming organic compounds. Yeah, we call it nomenclature. Okay, I've written the word in chat. You can all see the word in chat so that you become familiar with the word, not just with the pronunciation, really. As Shazay was asking me how to spell the word. Nomenclature simply means art of naming anything. It can be compounds, it can be living things, it can be anything. In science, we use the word nomenclature whenever we talk about how to name anything. Okay? Nomenclature exists in many science subjects, not just biology and chemistry. So that's what I was talking about. So I'm going to make sure that you do not have a hard time understanding any topic which is assumed by the next level's teacher to be already understood at the level of IGCSE or O levels, right? So बाकी teachers कराएं या ना कराएं, मैं nomenclature जरूर करवाता हूँ और थोड़ा सा boundary से ज़्यादा कराता हूँ. It might take a couple of days, it might take a maximum of 3 days, but once you're good with nomenclature, the whole of chapter number 10 and 11 would be much easier to understand in terms of naming the compounds. All right? Okay. Any questions before we wind up the class? And I'm going to wind up the class a little earlier than the actual time. All right. We're so happy that we even forgot our questions. We're so happy that we released at least 3 to 4 minutes early. So no question. So let's wind up the class. All right, class. Take care. Allah Hafiz.